We're on the 4.8 note guide, and I already asked students to find f of 2 and g of 2. What we want to do here is I'm going to color code these. Anytime I work with f, it's going to be blue. Anytime I work with g, it's going to be red. To find f of 2, you simply plug 2 in. I think by now you should be used to this notation. F of 2 means to go anywhere there was an x, blank squared plus blank, and replace it with a 2. 2 squared is 4. 4 plus 2 is 6. With g, the function was to take 6 times the input, and they want you to find g of 2. So you just replace the input with 2, and what do you get? 12. No questions? Great. Moving on to f of g of x. Now this is where you can use symbols to take one function and put it inside another. So before we do that, I want you to tell me what f of 3 would be. 3 squared plus 3, and you would get 9 plus 3 is 12. What would f of a look like? A squared plus a. So when they say f of x, the x is what you put in for the input, right? When they said, hey, put a 3 there, I put a 3 there and there. When they say put a 2 there, you put a 2 there and there. True? If I wanted to find f of a, I would put an a there and there. The thing in the parentheses replaces the x. All right? So what would f of star be? True. What would f of Henry be? So what's f of g of x? G of x squared plus g of x. All right? Are you with me there? Again, all you do is you take what is here and you plug it in there and there, right? Henry was Henry squared plus Henry. So g of x, you do g of x squared plus g of x. But we know g of x. It is something. What is it? 6x. So this is 6x. So instead of writing g of x squared plus g of x, you write 6x squared plus 6x. Okay. There's one more step. You can square 6x. When you have two things multiplied that are squared, you can square each of them. What's 6 squared? 36. What's x squared? X squared, 6x. This is the final answer. F of g of x is 36x squared plus 6x. Next, we're going to do g of f of x. And before we do that, let's work with the red pen, and let's take, by the way, g of x was 6x. What does this machine do to its inputs? What does this function do to the things that you put in? It multiplies them by 6, right? So what's g of 3? 6 times 3, which is 18. What's g of 9? 6 times 9, which is 54. What's g of negative 10? 6 times negative 10, which is negative 60. What's g of k? 6k. Yes. What's g? Whoops, that's not what I want. What's g G of smiley face. 6 smiley faces, okay? That's what that machine does to its input. So G of f of x would be 6 f of x's, right? What if I just said what's G of f? You'd say 6 f, and that would be the answer. Here it's what's G of f of x. The G machine takes what's in it times 6. What's in it? And what is f of x equal to? How do we know that? It says so right here. Okay? F of x is x squared plus x. So I replace f of x with what it's equal to. Okay? Someone asked, can't you distribute? Yes. The final answer would be 6x squared plus 6x. That's G of f of x. We've moved on to example 2, and we're looking at the one with the star next to it. And it says find f of G of x again. And again, what we have is a machine inside a machine. We have G of x doing its work inside f of x. Here's one common way of doing this. Let's do the two-color system again. All right? On the outside, we have f of x working. Inside it, we have G of x. What is G of x equal to? X squared minus 6. All I did there is I rewrote G of x with what it's equal to. Now I'm going to go to blue, and I'm going to say, okay, what if I asked you to find, I'm going to use the disappearing ink for a minute, f of 1. Wouldn't you do negative 3 times 1 plus 5? Right? It says take negative 3 times something plus 5. That's what f of x does. It takes the input times what? And then adds 5. So it takes the input times negative 3 and then adds 5. Well, the input isn't just 6. The input isn't just 8. It's this whole thing. The whole thing goes in there. X squared minus 6. So it's like saying, first you're going to do the G of x, x squared minus 6. Then you'll do the negative 3 times it plus 5. So we have the red function inside the blue function. All right? If you can simplify these, do so. And you can. You can take negative 3 and distribute it. What do you get? Negative 3x squared. Negative times negative is 3 times 6 is 18. And then what? Can we still simplify? You get negative 3x squared plus 23. All right. We're going to do the example directly above that, and we're going to find f of G of 4. And here's the technique that I often use to show students this part. When you have f of G of a number, here's how I want you to write it. Take the 4, plug it into G's equation, and tell me what you get. What's 4 squared? The students say 16. Minus 6, 10. That's a temporary answer that you now plug into F's equation. What's negative 3 times 10? Negative 30 plus 5. Negative 25. You see, when you take 4 and you put it into the G machine, then you take that answer and put it into the F machine, guess what you get? Hint, I'm circling it. Negative 25. What if we just put the 4 in here? Remember, this was f of g of x. What happens when you put 4 in there? What's 4 squared? What's 3 times 16? 48, but negative because of the negative 3. What's negative 48 plus 23? Negative 25. You remember the answer from above that I did this to? What's similar? It's the same number. Up here, they're telling you, take 4, put it into G and get an answer. Take that answer and put it into F and get a final answer. Down here, we just put it into our machine within a machine, and we got the same answer. All right? I want you to complete the examples on this page to the best of your abilities, and then go over them with me. Examples 1 and 2. Example 3 we'll do together.